Okay, notation for first derivative and second derivative. You guys good with those? Yes. Easy peasy. So what did the first derivative test do? Well, it's the one that you didn't show up for, so. Right. It found the absolute max bid by using your first derivative and set it equal to 0 to solve for it. Critical values, you found the absolute max, absolute min. So now we're doing the second derivative test. So you can determine whether critical value is a relative max or minimum without exploring the function is increasing or decreasing. So super exciting. So I love it. Yeah, it's my favorite. All right. So from the last lesson, I need to find where my critical values are at. So the first thing I do is I do. First thing I do is do my first derivative. So if I calculate my first derivative, 3x squared minus 3, set that equal to 0. So x is equal to plus or minus 1, right? Yeah, that's good. Okay, so obviously this table is calculating towards -1. This one's +1. So we have the first derivative. I did the second derivative for us too. So let's fill in the values. I know you're really excited to do this. So 3.75, 0.630, which makes sense because we just calculated that. Negative 5.7, negative 2.25. So if we were to look at this really quickly, which side is increasing and which side is decreasing? Decreasing, increasing? Are you sure? You guys are right. High, and where are we headed to? 0. So this is going to go decreasing. So this is our, even though they're positive values, I have it the other way, but I think I got it wrong in my notes. Relative max here, we know that's a relative max. So if we're at 3.75 and we're headed towards 0, that's decreasing. If we're at 0 and we're headed towards negative 0.75, negative 2.5, what's happening? We are still decreasing. If we did the second derivative, this would be -9, -6.6. This would be -6. This would be -5.4 and -3. I have these backwards. Because those are increasing, right? Yeah. So these would all be increasing values. Make sure I did all those maths right. Oh, I guess this is a good question. That's a relative, what, max or min? Neither, they're both decreasing, right? Doesn't change. All right, so let's do this one. This one's negative 2.25, negative 0.57, 0, which makes sense. What's happening there? Increasing. So it's increasing towards 0, and then from here it's still going up. And then this one does the same thing. It does 3, 5.45, positive 6, 6.6, positive 9. I wonder if I wrote positive on the notes. Losing my mind. Okay. Oh, I think I made a mistake. I hope it's fixed on yours. Just on page 2. So the second derivative test. So if the first derivative is 0, and the second derivative is greater than 0, then f of x has a relative minimum. If the first derivative is equal to 0, that's all it's saying is your critical values. Look at your second derivative at that same point. If it's less than 0, it's a relative min. Can you guys change that to a positive 9? Do you positive 9 or do you negative 9? You need to change it to positive 9. I circled it. My notes. All right. So determine the relative extremes using the second derivative test. So what's step 1? First derivative, get kind of critical values. So f prime of x equals 3x squared plus 6x plus 9. So that's going to be equal to 0. Take up the 3x squared. That does not work. Do you guys see what I did wrong? Should be 12x. Nobody caught that. Usually you're yelling at me by now. Wasn't that yesterday? Was that Friday? Oh, it's Friday. You guys aren't in the mood for my foolish math tricks. Okay, so we have 2 values. So to do the second derivative test, guess what you gotta find? The second derivative. They do that one, right? So all you're doing is you're saying these are my critical values. So I'm going to assess my second derivative at these critical values. So we'll do -3 first. So 6 times -3 plus 12 equals -6. Thanks. Okay. So if I go back to my rule, so if I find my critical value and it's less than 0, which -6 is it a maximum or a minimum? It's a maximum. So this would be a relative max. How can we know it's not an absolute? What kind of function do we have? Cubic, right? And so if we put -1 in there. So now we're evaluating the other critical value, which is -1. So 6 times -1 plus 12 is going to give me +6 this time. So this is your relative minimum. That's pretty easy, eh? So now you don't have to table of values, you don't have to assess anything. You can do the first derivative to find the critical values. second derivative to state whether it's max or min. You know, that's the table values. Yeah.
Like why is there like so it's -6?
So when your second derivative is less than 0, it's a relative maximum. If your second derivative is greater than 0, it's a relative min. So now we've lost the table of values that we had to do in A3 to figure out if it was increasing or decreasing, and then assess whether it was a max or min, and we can just do the second derivative test to tell you. Okay, so determine the relative extremes for this using the second derivative test. Easy peasy. Do your first derivative. So -6x squared. If I solve for that, what's x? I gotta set it equal to 0. So x is equal to 0. So now I'm going to do second derivative. I don't know what I do over here that makes it. So I'm going to evaluate the 0. So now I have a 0 there. What does that mean? So now we're saying what? There's no relative maximum. And we saw what that graph looked like, right? It was that drag on that cubic function. That's, maybe you missed it, but it was there. We talked about, like, it's just a drag on the graph. It's not a hump in either direction. It's just the drag through. So this has, if you have a 0, this has no relative maximum. And if you're unsure about this, I would suggest you use that handy-dandy graph calculator. Okay. You know there's lots of apps out there for your phone that you can. I do. If it gets me through my gate. Okay, these are going to be your max min problems from grade 11 that you loved so much. But we're going to solve them so much better and faster. Awesome. Wow, glad I went to grade 11 teachers. Okay. So, step 1, read the problem carefully. Take note of any given values or conditions. Feel good about that? You can do that. Assign variables to the known and unknown quantities. Identify which quantity needs to be optimized. So which quantity needs to either be maximized or minimized. These are just max min problems you've done before. Express the relationship between the quantity to be optimized and the other variables. If possible, draw a pretty picture. If necessary, express all the relationships between the variables on an equation. Express the quantity, blah, blah, blah. Finally, express your answer in clear and concise terms. Got it? Okay, you guys don't care. It's okay. All right, 2 natural numbers whose sum is 8 and their product is a maximum. Essentially, I can just give you your grade 11 assignments again and get you to do them using first and second derivatives. Okay, what do we know about natural numbers? Everything but 0, not really, but they're positive, they don't include 0, and they are whole numbers. Okay, what's the difference between whole and natural? Nope. What did I say wasn't in the naturals? What's in whole? There you go, that's the only difference between them. What's the difference between whole numbers and integers? Integers have negatives. Rational, anything that can be written as a fraction. So those are your decimals. So when we're talking about natural numbers, if I get a negative answer, I can reject it. If I get a negative critical value, I can reject it right away. So it says two natural numbers whose sum is 8. Right? So we have a max is a times b, because the product is a maximum, right? So I can't do anything when I'm dealing with two variables. So I need to take this one and rearrange it. So b is equal to 8 minus a. So I just rearrange the equations to equal a single variable. Now in this one, I've just created, I said b, you could write this and its equivalent expression to b. So max is equal to a, which is this a, times by the new b. So we're going to take the derivative of that. The reason why we're going to do that is because I need to find my critical value. The critical value tells you the x possibility where it will be a maximum. So I'm going to take the first derivative of that. So m prime. So I'm going to have 8 minus 2a. Set that derivative equal to 0. Or equals a. So now I'm just going to do the second derivative. Figure out if it's a max or a min. So that's just going to be negative 2, right? I can screw that up. So negative 2, even if a is 4, what is it? Negative 2, so what does that tell me? So we have a relative mass. I'm going to have rejected if this was negative 4. Because of the natural number statement, I need the second derivative to figure out positive or negative. It's okay that that one's negative. So what's my other value? So a plus b equals 8. If a is 4, then b also must be 4. I don't know if that's harder or easier. This is where everybody screws up, though, creating the equation. We completed the square. But really, you know what? I think we should just drop that completing the square. Like, I don't think I should teach it. And the reason why I say that is because if you know x is equal to negative b over 2a, if you know that, and you can find the vertex, the whole point of completing the square is to find the vertex. If you can use a formula to find the vertex, why would you do it that way? Whoa. Okay, things get a little bit more complicated with this one. We're done. We're walking away. Okay. So essentially what this is, just imagine you fold up here and here, and you make a three-dimensional box. I don't really know if I'm the one to be drawing this picture, but we'll try. Oh, look at that. Kind of looking like a three-dimensional object. So we know that the width here, that's your x. Because that's what you're folding the box up to be. So the width of that box is x. So it says a rectangular metal box, and the lid is made from sheet of this by this. Equal squares are cut from the corners, edges are turned up and soldered to make a box. Okay, so now we need to figure out our dimensions. So if I'm looking at this box, what would be the height of my box? Good try though, it's close. But this whole thing is 6. 6 minus 2x, because I cut those x's out, right? The whole thing was 6, and then I cut those 2 x's out. So this is going to be 6 minus 2x. What's the length? You guys are not just a pretty face, not just a hot wrap. Okay, so this is where we go past grade 11. It's asking find the dimensions for the box having a maximum volume and determine that volume. So how did I go past grade 11? All of a sudden we're dealing with cubes. In grade 11 we just stuck to squares. Now we're dealing with cubes. Because how do you find volume? Volume is length times width times height. So the volume of this box is going to be 16 minus 2x, 6 minus 2x, and x. I mean, I've done this in the correct order. Okay, so here's the thing. When we're doing first derivatives, what do you want to do? Do you want to do the product rule and simplify, or do you want to simplify this and then do the direct derivative? Simplify and direct derivative. I like where your head's at. And 96, 44x plus 4x squared by x. So you couldn't have solved this if you were in grade 11, because you didn't know how to do synthetic division, right? You didn't quite know how to deal with this yet. Actually, you probably could have, because you could have settled back to 0. But you're finding whether it's a max or min, so you're looking for the critical values. You haven't seen a cubic function yet. So once I have my function, what's the first thing I'm going to do? I need to find my critical values. So I'm doing B prime. I like when I talk to myself. It's my favorite part of the day. I'm doing a derivative. See? Talking to myself up here. Just talking to myself. Crying a little. Feel better? Yeah. Okay. So we're going to factor that. You can do this. Oh, B. So mostly me, but I got it. I took a 4 out of everything. Do you want me to give you the factors, or do you really want to try? It's like it's Friday. We had a deal. We weren't going to work hard. So if I set that equal to 0, okay. There's something that I can restrict right away. okay, we're gonna talk about restrictions. We missed a whole step. Step 2 was to talk about restrictions. We did step 1, which is beautiful, was create this equation. Step 2, we should have talked about the restrictions on the variables. Say what? So what are my restrictions? Yeah, they have, X does have to be positive, but if it was negative here, it would work in this case, but it wouldn't work here, right? So we know that X, call that the width. The width, X has to be greater than 0, right? I can't have a negative value there. So let's talk about the length. What's the deal with the length? So the length is 16 minus 2x. What do I know about that? So this has to be greater than 0, right? You guys would agree with me? So we're going to solve this. So x has to be less than 8. Can we do that? Because you guys are really good at solving inequalities, and you don't need all the steps. And then we're dealing with the height. So that one's 6 minus 2x, that has to be greater than 0. So x has to be less than 3. All right, so when we look at this, did I screw it up? Okay, so when we look at restrictions, they all apply to everything, right? We just talked about that. X can't be negative because of here. So we have to apply this restriction to everything. So X has to be greater than 0. Well, that's true here. Less than 3 and less than 8. Right? So what is our lower limit? 0. Because there's lots of values that are less than 3, like negative 60. That'd be a tough fight too. What's our maximum? 3, because we have a fight here, right? This one says less than 3, and this one says less than 8. Well, 3 is less than 8, so that satisfies that one, but 8 is not less than 3. So that one doesn't jive. So we're going to say our max is 3. So X has to be less than 3, but greater than 0. So with that knowledge, we're going to reject the 6. Does that make sense to everybody? Okay. All right. So with that information, we can move forward to doing our second derivative. We can do our second derivative. So run is equal to 24x minus 88. So what am I going to be substituting in there? 4 over 3. Relative max, relative min. Relative max. That proves that it's max. I don't need to find my vertex. Things are so much easier when you just factor and not have to find your vertex. Life's good. But the question's not done. So we found that at 4/3 it does have a relative max. Kudos. But the question says determine the dimensions and find the maximum volume. So now it's just subbing stuff in to actually answer the question. So the dimensions, what's the width? Yeah, and what's x equal to? 4/3 what? Centimeters? Okay. What's the length? So the length had an expression of 16 minus 2 times 4/3. You want to leave it as a fraction, or you want to do it as a decimal? Yeah, 13.3 repeating. I don't know what happened there. We're just going to roll with it. And then we get 16 minus 2 times 4/3. That's going to give me, I'm sorry, 6 minus, so 3.3 repeating. Okay, what's your new volume? What's your max volume? Guess what you're doing with all those dimensions? You're multiplying them all together. Uh, 59.3 centimeters cubed. I don't know if that's harder or easier than min, max, min. You probably feel a little bit more comfortable with them right now. Is that page? That's page 4. Let's do one more, so we're in a really good emotional place for Monday. One more, and this one's shorter than that one. Oh, you've done this 1,000,000 times. A 3-sided correct. I don't want to do it anymore. 160 meters of fencing. Constructed around a corral with a maximum area. One side of the corral is borders a river. Find the largest rectangular area that can be closed by 160 meters of fencing if no fence is needed along the river. Got it. So my first thing is I'm going to have 2W plus 1L equals 160. That's the statement for perimeter. Normally it's 2L, but I don't need that there. So what do you think I'm going to do with that? Make it equal to one variable. Welcome to Max Min problems. This was your life in grade 11. L is equal to 160 minus 2W. Okay. It's asking about the max area. How do I find area of a rectangle? Length times width. Well, lucky for me, we've already rearranged it. We can replace the L with that statement there. Remember when this stuff was really hard to grasp, like, wasn't fair, teachers were asking you to do terrible things. So here we need to complete the square, find the vertex, and calculate the max area. The nice thing about the vertex is that it tells you what the width would be, and then the y value, if you completed the square correctly, that was your max area. We're going to do it with derivatives. Okay, before we do the derivatives, let's talk about restrictions. So W has to be greater than 0. What about L? Okay, so L has to be greater than 0. But L I have a new statement for. Right, you would agree with that? So W is less than 80. I did that correctly? All right. So my domain is going to be from 0 to 80 with a W in between and all the area arrows pointing to the left. Okay, what do we do now? Stuff. We do the first derivative. So max is going to be 160 minus 4w. Yes. Set that equal to 0. And w is equal to 40. I did my math right. This one's way easier. Way easier. Does it satisfy the restriction? Proud of you. I don't know. I think it's overwhelming in grade 11 and 12 to think about your restrictions all the time. Really overwhelming in grade 11. We forced you to do it in grade 12. It's still a lot of stuff to see. Step 4, we're doing the second derivative to confirm that it's at a maximum. Second derivative is -4, so we know that that is a maximum. And so we know we have a maximum occurring when 40, when W is 40. So the question asks for the dimensions of the fencing. Did it ask for the max area? Okay. Alright. So answering the question step 5. So W is 40, what's L? 80. Did that happen in our heads? Okay, just making sure. And then what would be the max area? Max area would be 3,200 meters squared. Maximum problem don't seem so hard now. See? That took 3 minutes. You want to keep going? You sure? I don't know.